Right, okay, so last page of your booklet, we've got some graphs of motion for a bouncing ball. So I'm going to talk you through these. I've already drawn them in basically because I'm not very neat at drawing things, so it takes me a bit of time to draw them in. Obviously, it's still not very neat. So we've got displacement time graph, velocity time graph, and acceleration time graph. So the displacement time graph, and we're just discussing this at the front here, the way that I've drawn it is I've assumed that we're starting off because it's a drop ball being dropped. I've assumed that I started off at a positive displacement, and when I drop it, it goes to 0 again, and then it increases its displacement when it bounces back up and goes back down to 0, increases back down to 0. So this is it starting off, me holding it up, and then it going down to the ground, bouncing, then back up to a positive displacement, back down to the ground, bouncing, back up to the positive displacement. And this is the ideal case, so it should all be going back up to the same displacement each time. Okay. The velocity time graph, because I've decided that upwards is positive, I am dropping it, and it's going down the way. So it's increasing speed, but negatively. So it's getting a bigger negative value. And then when it bounces, straight away, it's positive again because it's going back, it's going up the way, but it will slow down as it gets higher up until it eventually gets to its highest point where the speed is 0. And then it starts going back down the way again until it bounces. Then straight away, we've got a high speed, but it slows down. Okay. And the acceleration time graph is actually the easiest graph because it's dropping, because we've got no other forces acting on it, it's dropping due to gravity. So we've got a negative gravitational field strength, negative acceleration due to gravity, because upwards is positive. Apart from when it bounces, when it's got that sudden acceleration in the opposite direction, but only when it bounces. Other than that, constantly at acceleration due to gravity. Yeah. So yeah, please do ask questions. And obviously these are all ideal, so they should reach the same sort of height here. Yes? So the way, yeah, so basically, this is it going down the way and it's increasing speed as it gets to the bottom. Yeah, yeah. Maybe downwards, upwards and downwards might be a better word, yeah. Okay, is that clear? I'll give you a bit of time to think it through. Okay. Yeah.
Would the acceleration change?
That you mean, but it will still be dropping. It will still be acceleration due to gravity.
Yeah.
These would change.
They wouldn't be as high.
Yeah. Yeah.
Would they be decreasing in height?
So, for a non-ideal case, it's the same shape, but the heights are getting less each time.